Hello boys and girls, and welcome to lesson 4 from chapter 3 on page 201, multiply decimals by decimals. Here we have a real world example where we have the weight of 1 pound object, on each planet. Now remember, the weight changes on Earth is 1 pound, but it changes from planet to planet because each planet has a different gravitational pull. The bigger the planet, the stronger the gravitational pull. Okay, so the higher the weight. Mercury is smaller than Earth, and 1 pound would be about 1/3 of a pound, 0.3, 30%. Venus, 0.9. So Venus and Earth are close to the same size, right? The weight is not that different. Earth is 1 pound. Mars is smaller, so the gravitational pull is less. Jupiter is much bigger. It's more than double the gravitational pull. It's 230%. Okay? And here we have Saturn. So Saturn and Earth have about the same gravitational pull. Now Saturn is a gas giant, while Earth is a solid, a rock. But they both have the same gravitational pull. Uranus and Neptune, you can see that. Okay, let's work on question 1. Number 1. A half-pound object weighs 1/2 as much as a 1 pound object. So half, right? If a cheeseburger weighs a half-pound on Earth, what will it weigh on Jupiter? So a half-pound can be represented by simply writing 0.5. And we're going to multiply it with the weight in Jupiter. So 1 here is 2.3 in Jupiter. But now what if it's a half here? It needs to be a half here. So what is a half here? Well, we find a half of a number by multiplying it by half. Right, 2.3. And it's going to give us 1.15 pounds. LBS. Okay, number 2. What would a barbell is what you put the weight on. What would a barbell that weighs 5 pounds on Earth weigh on Jupiter? 5 pounds. Well, we just realized that half a pound right over here, half a pound weighs 1.15. But if we move the decimal over, so now we're multiplying a whole number instead of a decimal, times 2.3, guess what? That's going to move the decimal over as well. So your answer is going to be 11.5, right? 11.5 lbs, libras, pounds. Okay, I hope that's making sense. Now, number 3, use the results from exercise 1 and 2 to find 0.05 times 2.3. Explain your answer. Now, boys and girls, we moved the decimal this way once, right? And we had a whole number, so we moved the decimal and the answer that way. But now they want to move it the other way. So what they're trying to tell us is to, I'll just move these guys out of the way here. What they're trying to tell us is to move it the other way now to 0.05. So we went this way now with our decimal, you see? Yeah? Times 2.3. What's going to happen with our decimal here? Well, if we went this way, remember we went this way, we must go this way as well. We went over 1, let's go over 1 in our answer. So if we do that, our answer should be 0.115. Correct? Okay, so we know it's 0.115, right? That's our answer. But here's another explanation. I'm telling you now to find 5 times 23. I've taken away the decimals from here and from here. What did I have to do the number? I had to go 1, 2 to the right, and here I had to go 1 to the right. So in total, I jumped 3 places to the right, right? 3 places to the right. I need to later on in my answer jump 3 places to the left so I can put it back in. So when I multiply 5 times 23, I'm going to get 115. But then I need to jump 3 places to the left, and that'll give me my answer. So if you take the decimals away, make sure you keep track of how many numbers you jump to the right, so that when you put them back in, you jump those numbers to the left again. If you copy this explanation exactly the way I've written it here, it goes to show that you've watched this video. So this right here is a key answer. On page 202, we're going to estimate before we find our answer. Remember, I told you to estimate. It's always good to get into the habit of estimating so that you know if your decimal is in the right place. Here, they want us to multiply 0.112 times 7.2. Now, if I were to do an estimate, I'm essentially multiplying 0.1 times 7. Or what I'm looking for is 1/10, right? 1 in the 10th place. 10% of 7. 10% of 7 means it's going to move our decimal place over to 1, and it will be 0.7. Okay? So that's my estimate. My estimate, I'm going to put 0.1 here times 7 is going to be 0.7. Okay? And now they want us to count the decimal places that we're going to work with. This one has 3 decimal places, 1, 2, 3. And this number, 7.2, has only 1 decimal place, right? So altogether, we have 3 plus 1, so we have 4 decimal places in total. So our answer will have 4 decimal places. Don't forget that. Okay, that's one way to make sure that your decimal place is in the right spot. Now let's go ahead and solve this. Please pause the video and multiply 2 times 2, 2 times 1, 2 times 1, 7 times 2, 7 times 1, 7 times 1. Fill it in, add it, and check your answer. I'm going to do it right now. Please pause. And here's my answer. After multiplying, I have 0.8064. Remember, we had 4 decimal places in total, so now I have 4 decimal places in total. So my answer is 0.84. Go ahead, put a star right there. Show me that you watched this video. Also, you can tell that my estimate was very close. I wrote 0.7 and the actual answer is 0.8. Okay, at the bottom of 202, we have these 3 questions to try. Let's go ahead and copy them down. Now, this is not like adding and subtracting where we have to align the decimals. So don't worry about that. Let's write them out so that we can multiply. Okay, I have mine written down. Now I'm going to go ahead and just multiply 8 times 7, 8 times 5, then 2 times 7, 2 times 5, add it up, and do the same with these 2. And then I'm not going to put my decimals in yet because I want to show you how I find where my decimal goes. Okay, here's my first one where I multiplied as I said I would, and everything I multiplied by 8, I put it right here, and then when I multiplied by 2, I skipped one number over and started writing them one after, right? And then I added, and now I just simply have to count the number of numbers I will jump to get from one decimal place to the other. Now remember, we always count clockwise. We go to the back of the number and come out of the back of the number. Okay, we don't count this way. Please don't make that mistake. So we go 1, 2. I jump 2 numbers, so I will do the same here. 1, 2, and my decimal place is right there. Okay, please try B and C on your own, and we will check them in class. Remind me, please write a big check near here so that you remind me. Let's check these in class. Okay, this may seem, this is on page 203. This may seem hard to estimate when you look at this question, but really, if you line it up like they've done so here, and you multiply 5 times 4, you know you have a 20. But where does the 20 fall? Well, the 20, because we're multiplying a larger number by a smaller number, we're actually looking for that fraction of this number. So it's going to fall in the 100th place. Okay, so there should be a 0.02 is your estimate. So that's what I'm going to write right over here just to see if we're going to be right. Okay, let's go ahead, pause the video, and try this multiplication here on your own. Pause now. Okay, just a quick review. We have 5 decimal places. 1, 2, 1, 2, 3. So we have 5 in total. 2 plus 3 is 5. So the product, our answer, will have 5 decimal places. That's the rule. I have multiplied, and I have 135 here and 225 here. Now I'm going to add. Okay, once I've added, this is what I have. I have 0.02385. Where does my decimal go? Well, we know that it's going to have 5 decimal places, or the way I've taught you to do it, just jump 1, 2, 3, 4, 5 to get back to the other decimal. So we do the same here. 1, 2, 3, 4, 5. And there's my decimal. Now look at my estimate. This was my estimate. So it wasn't too far off. Okay, let's multiply, let's check related whole numbers. So now we're just going to multiply the whole numbers without the decimals. please pause the video and try it on your own and then check your answer. Or if you've already done it, then just watch right through. Okay, when I just multiply the whole numbers, I get 2,385 after I add it up. But we know to move 5 places to the left because we have to get those decimal numbers back. So what is the number? Again, 1, 2, 3, 4, 5. There's going to be a 0 there, decimal 0. Okay? Okay, so write your answer right there. And is the answer the same? Yes, it is. Yes. So it's just multiplying whole numbers. Don't forget the decimal number of decimals you took away because you have to put them back in. That's the key answer. Write C as well in Spanish. Or yes in Spanish. Okay, now at the bottom of page 203, you will do these 3. Okay? Now, remember the estimate that I told you about where you're going to multiply, for example here, a 4 times a 3. Everyone knows that 4 times 3 is 12, but where's the 12? The 12 has to start in the 100th place. So my estimate for D, okay, my estimate is about 0.012. Okay, that's going to be my estimate because I'm multiplying this 3 times this 4 in the 100th place. It starts to count in the 100th place. Okay, set up your questions. Go ahead and solve them. Now remember, you multiply each number and then you add them at the bottom. Long multiplication, you add them, and then this one will have 4 decimal places. This one will have 5 decimal places. 1, 2, 3, 4, 5. This one will have 4 decimal places. Okay, let me know if my estimate is correct. Go ahead and try this on your own. And again, let's write the word check as our key answer, because I want to check these in class as part of our warm-up. Okay, now for a real world link. How does this apply to real world? A certain car can travel 28.45 miles, almost 28.5 miles, with 1 gallon of gasoline. 1 gallon. The gasoline tank can hold 11.5 gallons. How many miles can this car travel on a full tank of gas? Let's say we fill it up all the way up to 11.5 gallons. Justify your answer. Well, boys and girls, if we do have this much gasoline, and for each one of those gallons, we get this many, clearly we have to multiply. Now remember, your decimals don't have to align when you're multiplying because we have to count the decimal places anyways, right? So we multiply it like this, as you see here. And then when we multiply by 5, we get this. When we multiply by ones, we start under the ones and we get this. When we multiply by the ones again, you get the same answer. Remember, when you multiply by 1, you get exactly this number right there. Then when you add it up, you count the number of decimals, 1, 2, 3, and you count them in 1, 2, 3. And there's your decimal. So 327.175 is the number of miles a full tank of gas can ride. The car could travel 327.175 miles, since 327.17 miles is close to 360. What? The answer is reasonable. Wait a minute. The answer is reasonable. Well, it's reasonable, but because the decimal place falls in the right place, right? It's in the 300s. 300 and 300. But really, boys and girls, let's be honest here. If you want to drive 360 kilometers, if you're expecting to drive that far, you're not going to make it. You're going to be about 33 miles short. So I wouldn't consider this reasonable. This is an underestimate. It's better to be over. Now, if you had to drive 300 miles and this is what you get from your full tank gas, that's reasonable. That's reasonable to estimate that because you want to make sure you can drive more than what you need. That's a real world lesson there for you, everyone. Okay, and now leave the guided practice for class so that we can do this as a review, but you can work on the independent practice on your own. This is why it's independent. If you need to reference, go to examples 1 to 4 for that one. For the word problem, you can check example 5. You see that? So just do the independent page now on your own. See you in class.